All right, so today's lesson is on 2.6, proving geometric relationships. And so we're going to start with this angle proof reference sheet. And this is actually going to be on the very back of the segment proof reference sheet that we already started with. So hopefully you have that in your notes. And if you have this printed out, that's where you can find it. It's just on the back. And I'm going to go through these kind of quick. So if you ever need to pause the video and make sure that you're writing down everything that's on here, please do. So let's go ahead and get started. So the measure of angle A is equal to the measure of angle B. So then we know that angle A is congruent to angle B. Okay. Down here for complementary, we know that whenever we have complementary angles, they're going to equal 90. So measure of angle A plus measure of angle B is equal to 90 degrees. And then same thing for supplementary angles, they're always going to equal 180. So we have measure of angle A plus measure of angle B is 180 degrees. And then perpendicular lines, this is going to be denoted like this. Perpendicular lines are going to form right angles. And a right angle, just as a reminder, this is 90 degrees. Okay. So then now I'm down here at angle addition postulate. So just like segment addition and anything else that we've really used before, angle addition, we've used that before. So that just tells us if we add these two angles together, we're going to get the entire thing. So if we were to add angle ABD plus angle DBC, we are going to get the entire thing, which is angle ABC. Okay, so then the last thing that I need to write down on here, vertical angles theorem, if two angles are vertical, then they are congruent. Okay, so go ahead and pause the video and make sure that you get the rest of these theorems down. All right, so now we're on the back page, and now what I want you to do is go ahead and pause the video again and make sure that you have, make sure that you have all of this written down. So term definition, and I want you to draw a picture for it as well. Okay, so now that you have all of that written down, we're going to start with this first proof. So we're given a rectangle on the side here, and we're also given that the line segment AB is perpendicular to BC, and so we can see that these are perpendicular lines, right? And then we also know that AD, so I'm going to erase this really quick, we also know that AD is perpendicular to DC. So we're going to just write that in our first statement box. So we have AB is perpendicular to BC, and I'm just going to write them both in the same. AD is perpendicular to DC. And it's because it's given. All right, and so now, since we know that these line segments are perpendicular, we can tell something about them, but what I want you to do is go back to that angle reference sheet and see if you can figure out what our next statement line should be. So pause the video and just take a look at that. All right, so hopefully you pause the video and you found that whenever we have perpendicular lines, it means that we have right angles, aka 90-degree angles, right? But we're only trying to prove that angle B is congruent to angle D. So we just can start with that and say angle B and angle D, angle D are right. So they're right angles, right? And this is because it is the definition of perpendicular lines. Okay, and since we know that they're right angles and they're both equal to 90 degrees, then we can say that angle B is congruent to angle D. This is the right angles congruence. Okay, kind of ran out of room there a little bit, but it's the right angles congruence theorem. All right. Okay, moving on to this next page. We are given a couple triangles on the side here, and we're also given that angle 1 and angle 2 are supplementary, and we know that angle 3 and angle 2 are supplementary. So I'm going to start you off here. So I'm going to give you, oops. So angle 1 and angle 2 are supplementary, and it's because it's given to us, okay? And angle 3 and angle 2 are supplementary, also because it's given, okay? And then now I want you to pause the video and see if you can come up with the next place to go for our statement line. All right, so since we know that these angles are supplementary, then we know that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And that is the definition of supplementary. Okay, and if we know that, then we also know that the measure of angle 3 plus the measure of angle 2 is equal to 180 degrees. Again, because of the definition of supplementary angles. Okay. And now, hopefully you can see where I'm going with this. We're going to set these two lines equal to each other. So we can have measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. So we have the measure of angle 1 plus measure of angle 2 is equal to 180, and 180 is also equal to measure of angle 3 plus measure of angle 2. This is the transitive property. So we can just set the two equal to each other. Okay. Now hopefully you're seeing that we have measure of angle 2 on both sides. And so we can actually just subtract our measure of angle 2 in order to get measure of angle 1 is equal to measure of angle 3. And I just subtracted here. Okay. And last but not least, we're trying to prove that angle 1 is congruent to angle 3, and we're almost there. So we can just finish this out and say angle 1 is congruent to angle 3, and that's because it's the definition of congruent angles. All right. So go ahead and pause the video and work through example 3. All right, so hopefully you worked through this one already, and so you found that if measure of angle 1 is equal to 47, then measure of angle 2 right here is 43 degrees. And hopefully you saw that measure of angle 1 plus measure of angle 2 is supposed to equal 180 degrees. So if 1 equals 47, 2, there's no way that that can be 43. So this is actually going to be false. And we can tell because if we subtracted 47 from 180, we would get 133. So we know that measure of angle 2 is equal to 133 degrees. Okay. And then for part B, we know that if measure of 47 or measure of angle 1 is 47, then measure of angle 3 is 47, and this is true because they're vertical angles. Okay. And measure of angle 1 plus measure of angle 2, or measure of angle 3, is equal to 4 plus 2. And that wouldn't make sense because 1 and 3 are vertical angles. And so I think what they're trying to say here is that if we were to add the sides, then those are equal to each other because they're both going to be 180 degrees. So this would be false because vertical angles don't necessarily equal each other, because we can have measure of angle 1 plus measure of angle 2 is equal to measure of angle 4 plus measure of angle 3. Okay, and that's the same thing as what we just said. Basically, now it's just on opposite sides for part D. So we have measure of angle 1 plus 4 equals measure of angle 2 plus measure of angle 3, which would be 180 on both sides, so that is true. All right, so on this next one, we have vertical angles here. So whenever we have vertical angles, we always want to set them equal to each other. So I can start you off on this one and have 2x plus 3 is equal to 4x minus 101. So now what I want you to do is go ahead and solve for x and then plug it back in to find each of the angle measurements. So I want you to find what exactly these two angle measurements are. All right, so hopefully you paused the video and you found that x is equal to 52. So you should get 52. And then each of these is going to be 107 degrees because they are vertical angles. All right, so now your homework for tonight is just attached to this note sheet as well. So it's 2.6 homework. So what I want you to do is take this homework, complete it, and then submit it on Google Classroom just like we normally do. It is due on Friday at 11:59 p.m. This is your only assignment for the entire week, and it's only 9 problems. So please make sure that if you need help, you're asking questions, attend those office hours on Friday, and I will see you soon.